if you speak loud enough, it just goes off my microphone on my computer. So, all right. Yes. Start with a bell. Okay. Number 1 warm up here. We're going to be working on worksheet 4 in a second, covering all these concepts today, except I don't think we're doing this. I think I got carried away when I was checking things. All right. Anyway, what's happening here? Do we want to distribute? Oh, good idea. What do you want to do instead? Why do we not want to divide by 3 first? Okay, if we divided by 3, we'd have to divide the 11 by 3 as well, which doesn't sound very fun, right? $192? Now what? Okay. And then square root, and when you square root, we're going to remember x plus 1 equals plus or minus 8. And because it's pre-calc, I'm going to make you simplify that and tell me what 2 numbers that is, and nobody's going to make a silly mistake and get a 4 because they can't do that, right? -1 plus or minus 8 is positive 7, or, okay, use calculator. Never fear, use your calculator. You do get to use a scientific calculator on the quiz. All right, completing the square. Why is this not as much fun as it seems like completing the square could be? It's going to be a fraction or a decimal, okay? And you need an exact answer in the end if you want to work with fractions along the way, but when we go, we need a simplified answer at the end, so I'm going to do fractions. First of all, I'm going to rewrite it with blanks because it's completing the square. Then what? 9/2, and I'm just going to write it 9/2. Then I have to square this. Yes, I'm just going to take 9/2 times 9/2. So the top becomes 81, the bottom becomes 4. Now, you will have a scientific calculator. You can do this and change it to a decimal. How would you add without a calculator? Yes, you need a common denominator. So 17 times 4/4 plus 81/4 becomes 68. Did I do that right? We add the top and we get 149. Do we get 8 in the denominator? Keep the denominator when you add fractions, yes? Okay, how could you check that you did that right? Could you type 17 plus 81 divided by 4, and because you're going to have a scientific calculator, you get a decimal, see if you do 149 divided by 4, get the same decimal, right? Okay, now what? Square root, so we get x plus 9/2 equals plus or minus square root of 149, and in the denominator it's the square root of 4, so it's just plain old 2. I don't think 149 is divisible by much. Is it prime? I don't know. Anyway, I don't think it simplifies. So if we subtract 9/2, I think we're done. X equals -9/2 plus or minus the square root of 149/2, or you could write it as -9 plus or minus the square root of 149 all over 2, same thing. Questions? Can you do one of those? Now, this looks like an answer you would have gotten from quadratic formula. Could you do quadratic formula to check that you did completing the square right? Absolutely. But if the directions say solve by completing the square, guess what I'm going to be looking for? The work, right? All right. Ready? Today's stuff. Vertex form of a parabola is y equals a x minus h quantity squared plus k. What can you tell me? Okay. K is the y-intercept. Very good. What else can you tell me? H is the x value of the vertex. Can we just say that? HK is the vertex? Yeah. How would we find the x-intercepts if we wanted to? We're not going to do those till next week, but how do you find x-intercepts ever? Put what in for y? 0. Yeah, set it equal to 0. All right, what else can you tell me though? What does A do? The sign plus or minus tells you whether it opens up or down, right? And it's also the vertical stretch or shrink. If A, the absolute value of A is greater than 1, so what would a 2 there do? Or a negative 2? Does it make it skinnier or wider? Yes, it goes up and down faster, so it will appear skinnier. And an absolute value of A less than 1, like a 1/2 or a 1/3 or a 1/4 or a 0.8, make it appear wider because it actually goes up and down slower. It's like somebody sat on it. All right. So you don't have this slide. There's only one thing I really want to talk about is the axis of symmetry. But can you look at the equations and see that it reinforces what you know? This one opens up because it's got a positive 1 there. This one has a 1/3. It's not a very good picture. It would be wide if we continued. Yeah, like that. But it's opening up. This has a negative 1/10. So it's very wide open and opening down, reinforcing all those ideas. All right, this one had a 5 that made it really skinny, went up really fast. All right, what can you tell me about the axis of symmetry? What? Yes, it goes right down the middle. So it goes through what point? The vertex. All the parabolas we do in this unit are going to open either up or down. We're going to eventually do sideways parabolas and not just square root graphs. We're going to do actual parabolas where the y is squared and not the x, but not till second semester. For now, all of the axis of symmetry is a vertical line through the vertex. So what form would it have? Yes, x equals, and where's it going to go? Through the vertex. And what's the x of our vertex? H. We called it x equals h. So the axis of symmetry for all vertical parabolas will be x equals whatever the h value is of the vertex. We good? Easy peasy. All right, and remember these should be U-shaped, not V's, right? Okay. I want to show you a little trick. A normal parabola, anywhere we decide to slide it, but a normal parabola, when you go over 1 and then the y comes from squaring the x, it goes up 1 squared, right? If we put in a 2, it goes over how much? Or up how much? 2 squared or 4, yes? We put in a 3, it goes 3 squared or 9, which is probably off our graph paper, right? All right, I'm going to use this idea to help you find points really quickly. Now, I will tell you right now, if you struggle with the idea that I'm going to talk about right here, it's okay to use your calculator. I'm not going to take your calculator away from you in terms of finding other points. I just want to show you something that will help you graph these quickly. Where's the vertex on number 2? Positive 2, 1. Now, if I move 1 either way, there is an a value out here that's just 1, so it will go up or down 1 squared or 1. So over 1, up 1, over 1, up 1. When I go 2 either way, from the vertex, not from the origin, it will go up and down 2 squared, which is 4. So if I go back to the vertex and I go out 2, it will go up 4. Okay, this is just a little like hint that'll help you graph points faster. Now, what point did I just plot right there? 0, 5. Could I check that that works? If I put in a 0, I get 0 minus 2 is negative 2, squared is 4, 4 plus 1 is 5. Oh, it works. Okay, and when you graph it, try to make it rounded at the bottom so it doesn't look like a V. So who can talk me through number 3? Where do I start? Caleb, could you at least find your notes sheet? Albert, can you take some examples down? Perfect. All right. Now, my little funky rule about going left or right 1 either way, it's still going to go up or down 1 squared, but there was a negative 1 for the A, so it's going to go down, right? You always have to take any A value and multiply it by the square here to get the, again, if you don't like this idea, just use your calculators, okay? But it's going to go over 1, down 1. What do you think is going to happen when I do 2? What's negative 1 times 2 squared? That's supposed to be a 2, not a 1. Sorry. If I go either way, 2, it's going to go down 4. Everybody good? Square it. 2, 3, 4. We're just thinking about a regular parabola, and rather than going, adding things, subtracting things, and doing crazy things, we're just going off the vertex. This worksheet 4, guys. Everybody got it? All right. What's different this time? A is no longer 1. A is 2 here or 3 here. So it's going to go up or down faster, right? So vertex of this one. Good job. Positive 3, positive 2. I hope it opens down because otherwise we're out of graph paper, right? Okay. We're going to go 1 either way, left or right. And then we're going to go negative 2 times 1 squared, which is going to be, yeah, nope, you square the 1 first to get 1 times 2 would be negative 2. Yeah, it's going to go down 2. Negative 2, go out either way 1, it's going to go down 2. What happens if you go out either way 2, though? What's negative 2 times 2 squared? Do the square first. 2 squared is 4 times negative 2 is negative 8. So if you go out 2 from the vertex, it should go down 8. Okay. Can we check one of those ordered pairs? Whoa. What ordered pair do you want to try? Oh my goodness, that's a horrible picture. Is it at 5, negative 6, guys? Did anybody plot 5, negative 6 as one of their points? If I put a 5 back in, 5 minus 3 is 2, 2 squared is 4, 4 times negative 2 is negative 8, plus 2 is negative 6. I think it works. All right, so can you try this one? Find your vertex. And this time when you go 1 either way, it should go 3 times 1 squared up and down. Anybody find the y-intercept? What did we write back here? Was this true? I let us write that down. This is, K is not the y-intercept. K is the y value of the vertex. When we have this form, which is called standard form of a parabola, then this number at the back is going to be the intercept, because if we put in an x, oh, I lost out x. If we put in x equals 0, we'll get out c, right? So in this form, that's the y-intercept. But here, we wrote this down wrong. K is not the y-intercept. K is the y value of the vertex. That's my bad. I should have got that. I was like, oh, yeah, we're good. Genius. No. All right. How did we do on number 5? We okay? So I got 0, 8 as one of the ordered pairs. If I plug a 0 back in, I get negative 2 squared is 4, times 3 is 12, 12 minus 4 is 8. It seems okay? All right. This is going to work as well, but fractions aren't really our friend. Vertex for number 6, quick. Negative 4, positive 4. Okay, so this time when I go 1 either way, I'm going to go negative 1/2 times 1 squared, which is how much? That's just a half, right? So from this vertex, if I go over 1, I'm going to go down a half. Not a great ordered pair. If I go 2, though, what's negative 1/2 times 2 squared? 2 squared is 2 squared first is 4. Half of 4 is 2. So yes, it is negative 2. We're going to go down 2. From here, go out 2, down 2. Okay, now some of you are doubting me. I can tell. Thinking it's not working, Ms. Hoffbauer. We don't believe you. What is an ordered pair we went through? Negative 2, positive 2? Let's check it. Put a negative 2 in here. Negative 2 plus 4 is 2. 2 squared is 4. Half of 4 is 2. That one has a negative. So we're at negative 2 plus 4 is 2. Worked. Okay. Do we need to do one more, or you got this? Want to try this one because it's got a fraction? If you want to just use your calculator and find values, you can do that. Did you get 0, 5? If I put a 0 in back here, I get 4 when I square it. Half of 4 is 2. 2 plus 3 is 5. So I think 0, 5 should be on our... All right. Ready to move on? The whole rest of this is not about graphing. It's about solving. Why are we redoing solving by square rooting, solving by completing the square, solving by graph or factoring, solving by quadratic? What did we do yesterday that would cause us to redo all of these ideas? Complex numbers, imaginary numbers. So guess what? A lot of these are going to have imaginary solutions, okay? Now, I'm going to start with 9. 9 comes out pretty nice. What do we do first? Add 10, which is negative 28, and then we do what? Divide, we get n squared is negative 7. We square root both sides and get what? Plus or minus, because we square root a variable. And this is the square root of negative 1 times the square root of 7, which is I square root of 7. It is not I plus or minus the square root of 7. The I is multiplied by the square root of 7, right? All right. I skipped 8. Did anybody try 8? I thought, oh, these are about the same difference. So I was like, let's just do one of them. And then I realized that this one is way harder, I think, right? Because when you subtract 5, you get negative 76. Does that divide nicely by 10? We get n squared equals negative 76 over 10. We square root both sides and we get a plus or minus. Okay, the denominator is square root of 10. Up here I have the square root of negative 1 times the square root of 76. Does 4 go into 76 though? 19 times? How many of you are really bad at simplifying radicals? Okay, someone just asked me today for some extra practice on that. Someone asked me for extra practice, just made me cry. Okay, I got a worksheet. I'll make some copies. The answers will be on the back, but if you're really not good at this, if you need some hints about how to do it, I just break it down and look for perfect squares that go in. I can help you if you're having trouble with that simplifying radical business. Okay, so what is this one going to simplify to? There's an I, square root of 4 is 2, and square root of 19. I don't really like how we wrote that, but we'll go with it for now. Okay, evil math rule. Can we have a radical in the basement? Radicals. Those crazy radical people belong not in the basement, right? Okay, we have a 2 and an I. I'm going to write it in this order this time. 19 times 10 is 190, which is 5 times, how many times does 5 go into 190? 38. And 38 is just 19 times 2. So if the only things that go in there are 2, 5, and 19, is that seeming like anything? It's going to be a perfect square. Denominator square root of 10 is 10. I missed my plus or minus. Yes, I can reduce that. Can I reduce the 190 and the 10? No, one's in jail or radical, one's not, but I can reduce the 2 and the 10. Thank you, Miranda. Those are not in jail. Why is it okay to cross those out? Yes, perfect explanation. They're all multiplied together, not added or subtracted. Good job. So it's plus or minus I square root of 190 over 5. Okay. That was a disgusting question, yes? All right, solve by completing the square. If I remember right, this one is a radical and that one's not. So I think I'm going to skip 11. If you want to do it on your own, you can. But let's do 10. What do we need to do here? We can come back to 11 if we have time, but subtract the 91 to the other side so that we can put a plus blank. Good call. Okay, then what? Half of this is 5. We gotta square it so that this is equivalent to this, which would be 25. What's negative 91 plus 25? Negative 66. Okay, that seems right to me. If we square root, because we're supposed to solve, not just leave it, x plus 5, I don't know why I have parentheses, doesn't really need them anymore, plus or minus, okay, there's a square root of negative 1 that's going to come out as an I, right? But otherwise, 2 and 33, 3 and 22, 6 and 11, any perfect squares going in there? No. So what you're doing when you simplify radicals is you're looking through that list of perfect squares. 2 squared, 3 squared, 4 squared, 5 squared. Does any of those divide into 66? Okay. Can I skip 11? Solve by the method of your choice. Unfortunately, I don't think there's a section on the quiz that says that. You have to do whatever it says in the directions. What would you like to do first to number 12? Yes. I stopped too soon. Thank you for fixing me. Subtract the 5 over to the other side, and it should be negative 5 plus or minus I squared to 66. I totally didn't finish. If you wrote plus or minus I squared root to 66 minus 5, that would be fine. But it's not, like, the 5 is not multiplied, right? It's not plus or minus 5I squared. Just make sure you got it subtracted to one side or the other. Thank you. This is the right answer, not what I had. Nina gets extra candy today. All right, number 12. What else? What do I want to do first? My choice would always be to factor because it's fast, for me at least. Faster than quadratic formula. Actually, my first choice would probably be if it's one I can just like square root both sides, right? But this one definitely is not one I can square both sides. If I want to try factoring, what do I have to do first? Take out a 2. Now, we talked the other day about whether we could throw that away. What was our consensus? Do you remember? If it's set equal to 0, can't I divide both sides by 2? And if I divide both sides by 2, I get 0 still over here, right? So I can just throw that out. Now I have a squared plus a plus 4 equals 0. A factor? Only in our dreams. Okay. Does not factor. We could do completing the square. Does that sound fun? Not really. What's our next choice? Quadratic formula. A is 1, or the number in front of A, the coefficient. B is in front of the A term is 1, and C is 4. I'm just pretending this says x squared plus x plus 4. Is everybody okay with that? Just because I threw a different variable in there. Okay. The first question on the quiz about quadratics says, write the quadratic formula. Because if you get that wrong, how's the rest of that part going to go? Not so well. All right, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to send this problem to the next page. Maybe. Did that work? Yes, it did. Okay. So that I can write over here. All right. So what's happening for this problem? What is the opposite of b? Negative 1 plus or minus 1 squared, which is just 1, right? I like to square it in my head if I can. Minus 4 times a times c, which is also 4, all over 2a. I think I kind of like this problem, because I don't think it's going to simplify too much, is it? That's where I usually mess up, is I'm trying to simplify. Plus or minus, what's 1 minus 16? Square root of negative 15. What's the only thing I have to do to simplify? Well, that sounds painful. But yes, take out an I is the right answer. Everybody good? You like that one on the quiz? Not too much simplifying to mess up? Okay, let's try this one. Does it factor? No. A is 9, B is 4, and C is 5. Opposite of B is what? Negative 4 plus or minus, what's B squared? 16 minus 4 times A, which is 9, times C, which is 5. All over 2 times 9. I think we're going to have to do some simplifying this time. I put the 18 over each piece. let's see, 16 minus 180, is it negative 164? Is that right? Is that what somebody said? Thanks. Okay. Remember, I like to break it apart so that I don't cancel the 18 wrong. So negative 4/18 reduces to negative 2/9. Okay, let's break this apart. We have a negative 1. Doesn't 4 go into there? 41 times? Well, that seems like a nice number because 41 is nice prime. We can't break that down any further. So what do we get? An I, and a 2, and a square root of 41, right? 2i square roots of 41, but it's still over 18, so can we reduce that? Yes, because I broke it apart, so now this goes in here 9 times. If you wanted to rewrite it again all as one fraction, it's negative 2 plus or minus I square root of 41 all over 9, but you can leave it separate. Did I do something wrong? Square root of 4 was 2i, and then I reduced it with the 18. You good? Yeah, please ask, because I will do something wrong, as Nina has proven today. And I proved at the beginning when I tried to tell you it was an XY intercept. Pick one more. 15, does 15 factor? Can I take out a 2? I have 3x, oh, not 5, 3x squared minus 5x plus 5. I don't think that factors though, does it? I think 14 factors if you want to go back and do that one. We can do this one to finish quadratic, but I kind of want to do 16. What happens on 16? If those subtract off, we have 11n squared plus 4 equals 0. Do we need to do quadratic formula there? We could. What else could we do? Square rooting, yeah, but it's not going to be nice. We have n squared equals negative 4/11. Ugh. What do we get on the top? Plus or minus 2i. But then we have over the square root of 11, so we got to do that stupid square root of 11 over square root of 11 business. All right, I'm going to go back and do this one. Opposite of b plus or minus b squared would be 25 minus 4ac. I think this one's going to have imaginary answers again. All over 2a. Writing it over here. 5 plus or minus, what is that? 60, negative 35? Oh, it doesn't simplify, I don't think. It's nice. 5 plus or minus I square root of 35 over 6. Did someone else get that? Trust Anthony to check my work. Okay, so what's the homework? Worksheet 5, you only have to do the ones that are circled. There's 10 or less, I promise, okay? You want more practice? You can do all of worksheet 5. Tomorrow we're going to review for Thursday's summative. It has on it factoring, it has quadratic formula, it has completing the square, it has review, writing equations. Oh, and complex numbers. I knew I forgot something.